Mr. Seaman. Yeah, that's
Thanks,
fine.
thanks, Abdullah. So I'm Tim Kruger.
Yeah.
I've been working on carbon dioxide removal for the
Wow.
past 18 years, 12 of which running a program at the University of Oxford, assessing the whole range of proposed techniques from both an engineering perspective, but also from a social and policy perspective as well. I'm involved in a company that I founded called Origin, which uses the Lime cycle to take CO2 out of the atmosphere.
Oh,
And I'm a co-founder of Carbon Gap, an advocacy organization that works with European policymakers.
mm,
Over the past 3 years, Michael and I have worked together in the UAE, and we've been
okay.
working with the UAE government, exploring the idea of setting up an international agency for carbon
Yeah.
dioxide removal. So
Oh,
I'll leave it
wow.
there. Tell me about
Yeah,
yourself, Abdullah.
that's a great one. Yeah, sure. Uh, so my name is Abdullah, and I'm currently doing my master's at Memorial University of Newfoundland. So I'm working on CO2 conversion to methanol
Mhm.
and using photocatalytic technology, and that's what we'll discuss today when I open the slides. And I have been also a part of like Young Future Energy Leaders program, which is held at Abu Dhabi by Khalifa University. So that's how I visited the last time to Abu Dhabi and the World Energy Summit. And yeah, that's all.
Okay. So tell me a
Tim, we're
little
getting
bit
a bit
about
of
this.
feedback from behind you there. Maybe
Is
might
that
have to
me
get you.
or
No, I think it's whoever's talking in your background. Yeah.
oh, I can't hear them. But anyway,
Okay.
sorry about that.
No
But
worries.
yeah, tell me a little bit about what you're doing with this
Yeah,
photocatalytic approach for methanol.
sure, sure. I will just share my PPT. So just a moment, I'm not able. Um, yeah, no, it's okay. So is my screen shared, right?
Not
Not
yet,
yet.
but
There we are. Yeah.
now it is.
We
Yeah.
can see your the
Yeah,
email there. Yeah.
yeah, sure.
There you are. Yeah.
So yeah, and yeah, so we are actually working on building some. So currently, I'm working in the lab building a like modular powered solar powered system that can use photocatalyst to convert the dissolved CO2 in seawater into green methanol and hydrogen. And that we can use green methanol as a fuel for the industry or for the feedstocks as an alternative fuel for shipping. And this was the plan which we made for submitting it one of the competition at the MOM
Mhm.
KFUPM. So it was the venture craft competition, but unfortunately that was postponed. So yeah, this is the challenge which the maritime industry is facing, is about the regulatory framework in order to reduce the emissions which they are currently emitting due to fossil-based fuels. And also there is a demand for the global methanol production. So there's a demand for methanol for various purposes such as feedstocks and also being used as a fuel and also being used for running the marine vessels. And as we know that the other other technologies of carbon conversion are usually energy intensive. So this is the main this is the main diagram of our process. So which actually is to use a photocatalyst in order to convert the CO2 which is dissolved in seawater into methanol. So it just utilizes the photocatalyst, and which is composed of two semiconductor materials, and and there is exposure to the sunlight or visible light, which could be visible light from the sunlight, or in our lab we are using the UV light, which is converted into visible light for this purpose. And this leads to the conversion of methanol using the 6-step process. So there is a water splitting. So this photocatalyst is capable of splitting the water into hydrogen and oxygen, and then utilizing that hydrogen back and forth to convert the CO2 into methanol. And this is the other part which we think of integrating it, because if in order to increase the efficiency of the process, this photocatalytic process itself is capable of conversion, but if we integrate it with external process such as electrolysis or renewable electrolysis, that would lead to increasing the efficiency of the photocatalytic conversion. And so this is the whole idea. And this is the photocatalyst which we design in the lab, so which is composed of two materials and which has certain band gap, both of the materials, and we can modify this photocatalyst. The major role is played by this photocatalyst, which leads to a change in the product. So different if we design the photocatalyst in such a way that it leads to the production of methanol, this a different kind of photocatalyst or arrangement could lead to the production of carbon monoxide or methane. And this process also has byproducts such as ethanol, and which is in very little amount, and also we have methane and carbon monoxide. And so the idea is to actually use this green methanol, which is produced from this process, to as a fuel and also feedstocks. And also, if we are integrating the process, we could even get green hydrogen from the process, which could be again used as a fuel. And that leads to the dual revenue. So you have the revenue from the green methanol and the green hydrogen, and also leading to the reduced scope 1 and scope 3 emissions and eligible for the carbon credits trading. And so this was already mentioned regarding the market opportunity for methanol. And there are companies such as Maersk, which has methanol fired vessels, and Brazil runs few cars on methanol in the current infrastructure itself. And also China uses like blending of methanol with fuels in order to reduce the emissions. And this would be the impact from using methanol. So here we are focusing on producing a circular economy of carbon dioxide. So where we have the carbon dioxide and we convert it into methanol, and this methanol goes back into the environment, and then we have that circular economy of the carbon. Yeah. I think I will. Yeah.
Thank you for that. I've got a few thoughts. Maybe if we pause on this slide here. We've got questions about the energy, the overall carbon balance, and also the cost. So those are the three things that I've got there. So effectively what you're doing is you're extracting CO2 from seawater and turning it into methanol. And that obviously requires an investment of energy to achieve that, whether it's solar or hydrogen. The hydrogen itself is effectively solar. So you're putting energy in to make that methanol. Obviously, if you burn methanol in air, you produce CO2 and water vapor, releases energy. That's why you're producing the methanol, so that you can release that chemical energy. What is the energy efficiency of your process going from CO2 and water to methanol? So how much energy do you put in for the amount of energy that you would get back out from the combustion of the methanol?
Yeah. Also, I would like to mention that the reaction could even take place in the seawater. As currently in the lab, we are using DI water, and we are trying to dissolve CO2 into the DI water so that the reaction can take place.
Sure.
Yeah.
Sure. But I mean, the question I've got is how much energy is required to produce the methanol, how much energy is required?
I understand. So since this is at an early stage, we are just working in the lab, and so we have not yet calculated up or reach up to a value which we could explain it, or which we could mention.
Okay. But I think this is an important consideration,
right?
Because it's always going to be more than the energy that you can recover. So there is an energy efficiency question that needs to be answered, and I think it's important to do that.
Yeah.
I think the second thing I'd ask is you look at this as as a low carbon fuel. And to an extent, that's true. But obviously, when you burn the methanol, the CO2 is released back into the air. So it's not removing CO2, it's avoiding emission of CO2. And I think there's some benefit here in that you're using sunlight to drive this process to generate the fuel. And I think it's neat. And I can think of one application where this could really make sense.
Yeah.
But I'm not sure it makes sense necessarily from an environmental point of view, and I'll explain why. So I think where it makes sense is, and this is something, so if you have an aircraft carrier,
Right.
it needs to be supplied with aviation fuel for
Right.
the jets that are there.
So the SAF, Sustainable Aviation Fuel?
No.
Okay.
I'm talking about an aircraft carrier, so a warship that has aircraft on it.
Yeah.
They need to be supplied with aviation fuel. Yeah. So in order to fly your jets, you need aviation fuel. And from a security point of view, that is a problem because if you have ships going to your aircraft carrier, then you can tell whether, you have a vulnerability there. And so
Okay.
one thought, and I've seen this elsewhere, other people thought about it. Can you generate fuel for your aviation, for your planes on the aircraft carrier? And this is a technology that would do that. And so that is what you've got here is an approach that would work for that. But I suspect it would be, and so in those circumstances where you have a high value to the fuel because of all the fact that it's military, this would make sense. But conventionally, because when you burn the fuel, you're releasing the CO2 back out, it probably doesn't make sense economically.
Yeah.
Can I also ask, what do you expect the price of the methanol to be with this approach?
So the expected price when we proposed it to make it like 3 times but that's not something feasible. So it would be something like 2 times the current fuel which we have, like the methanol from other sources such as the fossil-based source. So the main target would be actually the regulatory framework. So we target those industries or those companies where there is a pressure of regulatory in order to decarbonize.
Yeah. So, and I think, you briefly mentioned sustainable aviation fuel, and I think this is an approach of making SAF. To be honest, I'm not a huge fan of SAF because I think it is an expensive way of avoiding emissions. And so I think it's really important when you're doing this analysis is to understand how much it is costing to do this, because if you're trying to avoid emissions and the cost of avoiding emissions is really high, then it won't be economic to do it. And without that information, I can't really make a judgment on this as an approach.
Oh, right. So as like techno-economic analysis, right?
Yeah.
But let's consider if idea, like if the cost was not a reason for declining this idea, what would be the other factors or other challenges that would lead to decline of this technology?
Yeah. So I think, obviously you've done tests in a lab with deionized water. Seawater is a highly corrosive material.
Right.
And it also has biology going on in it as well.
That's right.
And so if you're looking to deploy this, if you require deionized water, that's going to be really expensive. If you want to do this directly in seawater, then you need to make sure that whatever your solution is here, or the technology that you have, it's robust to seawater conditions. So that's a consideration as well that you need to think of.
Yeah, like currently in the lab, we just use a container which is like made up of glass,
Hmm.
So we do not have like highly specialized container for doing this, and even the so as we know that the pressure requirement for dissolving the CO2 in the water, so that's around like 0.2 megapascal, so it's not that huge. Um, Regarding the containers, this is the benefit of the technology, that we do not need something like very specialized one.
Yeah, I can understand that, but when you're dissolving the
Oh yeah.
CO2 at that low pressure, you're doing it because you have pure CO2, but the ambient environment isn't low CO, it isn't pure CO2. So that's going to be a challenge.
Yes.
And if you think about having a clear container in the ocean, it's not going to stay clear for long. You've got salt in there, you've got wave action, which is going to place physical constraints on the materials as well.
Yeah, that's
So
right.
it it is a challenge.
Yeah.
I think what you described with um, the energy system and how it generates the methanol. I think that's really interesting. I'm not convinced that this is something that is going to actually reduce emissions in
Okay.
a way that is cost effective to do so. So that would be my concern. Yeah,
Yes. Yeah.
yeah.
Mm.
Um, I'm really sorry, but I have to go.
Oh, okay.
But
Sure.
I'm happy to have another conversation with you another
Yeah,
time.
sure. No worries.
But
We can schedule it at a
yeah,
later time when you are when at
yeah.
as per your convenience. No worries. Thank you very much for your insights. I just noted it down,
Okay.
and thank you very
No, no
much.
worries at all.
Yeah,
Okay, and
we'll connect. Yeah.
we'll connect. And Michael, sorry, I've got to go now, but
Yeah.
I'll get in touch with you in a bit.
Okay, sounds good. Yeah.
Sure.
Okay. Cheers.
Thank you.
Bye for
Thank
now.
you. Bye.
Thanks, Tim. Yeah, very good.
Oh,
Yeah, Abdullah,
yeah.
yeah, I think the key pieces there would be the overall carbon
Yeah.
balance, and
Right.
then the energy input costs is always a key one, and then ultimately it comes down to economics. Economics always comes at the end
Right.
because once you get scaled, the prices drop. But yeah, the energy balance or the energy requirements is can be a key piece
Yeah.
on what you're getting. Well, I mean, if you're going solar, then
Yeah, that's right.
it's
And
free energy. You still got to pay for your panel, but like it's a mission-free energy.
yeah, yeah.
Yeah.
And the thing is that this technology is at very low TR level currently.
Mhm.
So
Yeah.
more of the efforts are being made to actually increase the TRL of the technology.
Yes.
And
Yeah.
what I found, like from these interviews, and so I conducted like 20 interviews till now, and I plan to conduct more. And what I found is there is only one company in UK which actually has a similar project, but but I had a chat with them yesterday on similar interview, and they explained me that uh, since we do not have something like a specialized reactor for this purpose, we cannot even determine like what would be the cost of getting a reactor for running at the pilot scale, because you do not
Mhm.
have such reactors.
Yeah. Yeah.
And another concern for them, they just began this process and they have just developed the catalyst for now, and they
Mhm.
are trying to get fundings to scale it up. So they received fundings from the UK government, it's like 200,000 funding, to just scale up their, to just begin this process.
Yeah.
And yeah, there are challenges. There are also safety aspects, and Mr. Tim gave a very good overview, so I just noted it
Mhm.
down, and those are like some of the great insights which I did not receive from other people too, and some of
Yeah.
them matched. And and yeah, so I
Good.
think that it needs some more research field
Yeah.
in this work. Yeah,
And actually, like Tim's comment there on the aircraft
yeah,
carriers. So
right.
this is one area that the militaries have been looking quite a lot at is like a transportable fuel that they can basically make as they travel. And
Yeah,
it,
right.
it might be worth engaging with them as well as perhaps even the Coast Guard to look at
Yes,
what they have near the coast. But
this is
um,
a
yeah,
yeah, this
and
is a
but with the military aspects, it would probably be good to find out like depending on the size, like if you were to scale this, could you put your catalyst, your clear tank like in an engine room where I
Right.
don't know if the heat helps at all, but I mean it's always warmer in an engine room, but often they have flush buys on the engines to
Right.
cool them. So
Yeah.
they have an intake of water, and could that go past your catalyst? And do they have space on an aircraft carrier? Because might be like they might actually have an idea on, because I know they've been looking at methanol from like seawater to methanol aspects, but they might already have something like on a, can they scale it smaller to get more output? And yeah, it might be something to consider. So
Yeah, that's right.
yeah.
And also, yeah, it holds challenges. And the thing is, as you mentioned, the Coast Guard, yeah, I was trying to mention this point. So I had a meeting with one of the Port of Halifax, so the
Mhm.
executive director, and he gave the same viewpoint that this could be the Coast Guard could be the one who would be like early adopter of
Yeah.
such kind of technology.
Yes.
So
Yeah.
I think I will try to connect with Coast Guard. This program actually ends in July, but I'll just try to do it even later on.
Yeah. Yeah.
So currently, I'm trying to even get funds to do this process and also reason to do for the IP. So currently, I'm working under the supervisor, so under
Mhm.
NRCan project. So
Yeah.
this is like NRCan project, and then I got it same project I got for the Ocean Idea Challenge,
Yeah.
and then I look further to actually get some fundings in order to increase the efficiency of, in order to work more on this
Mhm.
project. Yeah.
Yeah. Oh, very good. Yeah, no,
Yeah,
Enercan's a great group to get in. And then even if you can
right.
transfer from, like they might even have different, the only thing is like Alberta has a pet chem
Yeah,
incentive
Alberta,
program,
yeah, they
but
have the Alberta Innovators.
yeah, 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 exactly. And they've
Yeah,
been good. And Saskatchewan had PTRC, but that was
of
more the
course.
petroleum side of things. But Sask, what is it? It's like Sask. It's the equivalent of Alberta Innovations or
Yeah,
Innovators in Saskatchewan, and they've been good. There's not a lot of sea though, not a lot
yeah,
of ocean water there, but
yeah. The
I think each province should have their own innovation
advantages,
groups. Yeah,
yeah, right.
yeah.
The thing I'm thinking on like what would be the methanol considered in this case because uh I also understand that the methanol which you have it would again emit the CO2. But
Mhm.
my idea was like if you just keep using those CO2 again and captured CO2 and just use this process back and forth in order to
Mhm.
create a circular economy. That was the whole idea behind it. So I'm just wondering like how would it make a story of reducing emissions?
Mhm.
Or does it actually do or does or not?
Yeah, yeah. So I mean, it'll come down to, is it emission, as Tim mentioned, emission avoidance, or is it emission removal? And
Okay.
I mean, those are two distinct
Yeah.
aspects. So often you can get a carbon credit for removal, but if it's just reducing, or if it's avoiding an emission in a different phase of it, then you may not be eligible for that carbon credit component. So
Oh yeah.
it's I think, yeah, I mean, if you're taking the CO2 out of the ocean and then that's going into the methanol, and I mean, that can be what is it on their map there? The CO2 is on where is that? Up at the top, is it? Yeah, CO2
Yeah.
and yeah, plus hydrogen. Yeah. Okay. And then, yeah, and then you're turning that into the methanol. So it's your hydrogen coming
Uh, Actually,
off the
the
separator. Yeah.
so this in itself is actually a process. So the photocatalyst itself can break into hydrogen. We do not require an
Mm.
external hydrogen to carry out the process.
Okay. Okay.
Yes,
Yeah.
that was the point, and I'm thinking to make another diagram because this confuses
Mhm.
in an indication that the
Yeah.
hydrogen we are trying to outsource it.
Yeah.
Yeah, as a
Yeah.
reactant,
Yeah.
but no, that's not the point. The
It's
photocatalyst
part
itself,
of the process. Yeah.
the hydrogen, yeah, the photocatalyst itself is capable of breaking down the water into hydrogen and oxygen.
Yeah. Yeah.
Yeah.
Oh, okay. Okay.
Yeah.
Yeah. Well, I misspelled that. So yeah, I think that would be a big step because it's that generation of the hydrogen, which
Oh,
actually you might even just stop at hydrogen in some aspects,
yes.
but you got to be able to sequester your
The
CO2 then.
Yeah,
But
that was the point. Like you could just stop on hydrogen, but
yeah,
hydrogen itself faces storage issues and
yes.
transport
Yeah.
issues.
Yeah.
So once we convert into something which is feasible, such as liquid fuel, it's
Yeah.
much easier to store
Yeah.
and
Transport
transport
it.
as compared to
Yeah.
hydrogen. That's
Yeah.
why we target on the methanol rather than targeting on the
Yeah.
hydrogen.
Yeah, because one of the things, like a lot of people are taking the hydrogen to um, ammonia, and then, but that still has
Yeah,
complications
that
in handling a
yeah,
bit. So now
breaking
they're going
down
to
the
ammonia
yeah,
nitrate. And so you're basically taking like blasting granules, and then
yeah,
you can stick that in a bag or in a box, and then but it's how do you convert it back to the fuel? So
ammonium nitrate.
ammonium nitrate, yeah. So there's a big
I
ammonium nitrate
think.
plant being built in Fujairah in the
uh,
United Arab Emirates. And
okay.
yeah, so it was started right before the war began.
Oh,
But
so do
it
you
was part of
plan
it was
to?
the transport of hydrogen and how do they move it? Yeah.
Yeah, right. I think I'm done with